All right, so we're going to continue Unit 1, Day 7 notes, and now we're going to talk about my absolute favorite math term in the entire world, asymptote. Control your excitement, please. So, asymptote, it's my absolute favorite math word, for obvious reasons. It's asymptote. It's good stuff. Anyways, I'm going to determine whether there is a vertical asymptote or a horizontal asymptote. Who here knows what an asymptote is, first of all? Anyone know? That's okay if no one knows. So an asymptote is just a vertical or horizontal line that the graph never touches. It gets really, really, really close to it, but it never touches it or crosses it. So, for example, I can find any asymptotes, whether they are vertical or horizontal, for any function they give me. If they give me this function right here, okay, f of x is 2x squared over 4 minus x squared. Well, in order to find vertical asymptotes, all we got to do is figure out where x cannot exist. All right? So when I have 2x squared over 4 minus x squared, all right, what values of x make that undefined? Anyone? 2. There's another one. Okay. 2 and negative 2. 2 and negative 2. First of all, what makes a fraction undefined?
0.
The denominator cannot be 0. Okay? So all I've got to do is figure out, well, what values make the denominator equal to 0? All right? And I can do this simply. I just add x squared to both sides. So 4 equals x squared. And how do I solve for x at that point? Yeah, the opposite of squaring is square rooting. I take the square root of both sides. So now, my square and my square root cancel. So x equals the square root of 4, which is 2. But be careful, whenever you work backwards from a square, it's always plus or minus. And if we look at that on the graph, well, it's x equals. Vertical is always going to be an x equal. Isn't a vertical line a graph? It's x equals 2. That's a vertical line right where x is 2. Then a horizontal, it's vertical. So my verticals are always going to be x equals. So let's look at this. On our graph, this is the graph right here. 2x squared minus, 2x squared over 4 minus x squared. And if I look, what happens at 2 and negative 2? Here's 2. That's negative 2. And here's positive 2. By the way, servers still count people in videos right now. So if you can catch me making a mistake. And I didn't sleep a lot last night, so they're there. Right here's our dashed line. Guess what? Look at the graph never touches it. It just gets closer and closer and never touches it. And it never will. That's how you find vertical asymptotes. You just figure out what values of x make the function undefined. In this case, since it's a fraction, what value of x makes the bottom 0? Because you can't have 0 in the bottom of a fraction. Horizontal asymptotes are a little bit different. This is kind of, you guys look like you all want to say something, but you don't because the thing is right. No? Yes. Still a class. You still have a suggestion or a comment. Go ahead. All right. So, this is calculus stuff, by the way. This is stuff that you'll do in calculus, so you move on to calculus. So, vertical was we figured out what value of x makes our function undefined, and we drew our 2 vertical lines, and those were our asymptotes. Now, what about horizontal? Horizontal actually is a little bit easier. Horizontal is actually a little bit easier. I take my function, okay? I say 2x squared over 4 minus x squared. This is something that might be new to you. We write it like this. I want to figure out what happens as x gets bigger and bigger and bigger and bigger to the right, and bigger and bigger and bigger to the left, which means it goes to positive infinity and negative infinity. And I say that it's the limit as x approaches positive infinity or negative infinity. All right? That's the proper notation. It's the limit as x approaches positive or negative infinity. But it's really simple. Don't let the infinity symbol like scare you off or whatever. It's really actually simple. The one thing I got to do is I keep the biggest term on the top of the fraction and the biggest term on the bottom. So I look at my numerator and denominator and just keep the biggest term. So if you want to make a note there, keep big term from numerator, and I abbreviate, you know that, and denominator. And then you just simplify. All right? So, what's the biggest term in the numerator? There's only one term, isn't there? There's only one term. So this is the biggest term on the top. I've got 2x squared. What's the biggest term on the bottom? Which term is bigger? The 4 or the x squared? The x squared. The biggest exponent. That's the biggest term. Question.
Is it bigger even though it's negative?
Yes. Yes. Good question. Whether it's positive, yes.
It's positive.
When you square it, it will be positive. If you square the negative, in this case, you won't. But the biggest term is always the one with the biggest exponent. And you got to keep the sign. Negative x squared. Now, I want to plug infinity into x. But I'm going to wait. Can I simplify that any? What can I do? The x squareds cancel, right? The x squareds cancel. So I end up with negative 2, right? Because it's in that secondly a 1. 2 over negative 1 is negative 2. I still want to try to plug in positive and negative infinity in for x. But are there any x's left over? No. So there's nothing to plug infinity to, so guess what? My horizontal lines are y equals, right? I have a horizontal asymptote at negative 2. Horizontal asymptote at negative 2. So let's look at our graph. Here's negative 2 on the y-axis. There's our horizontal axis. That's it. So for vertical, what value of x makes it undefined? That's where your vertical asymptotes are. For horizontal, I keep the biggest term on the top, the biggest term on the bottom, and I simplify. But here's a question. What happens when I simplify? There's still an x in there, and I got to put an infinity into that x. There are two possible situations. There will either be an infinity on the top or an infinity on the bottom. What if I have something where I simplify it, and I still want x to approach infinity, and I end up, after simplifying it, 1 over x. I need to put infinity in for x. Don't everybody look all excited. Killing me. What happens to a fraction as the bottom is bigger and bigger but the top stays the same? What's the overall value? It gets smaller, right? What's 1 over 1? It's 1. What's 1 over 2? It's half. That's smaller than 1. What's 1 over 3? It's a third. Smaller than half. 1 over 4 is a quarter, and so forth. So this will approach what? As the value gets smaller and smaller and smaller, what is it going to approach? It approaches 0. So in a situation like this, your asymptote will be at y equals 0. It doesn't matter if it's 1 over 3 infinity, 1 over infinity squared, whatever. If the infinity's on the bottom and there's nothing on the top, no infinity on the top, it would approach 0. Now what happens if it was vice versa? What happens if we have the limits as x approaches infinity of, we have x over 2? Well, now my infinity goes on the top, right? What does that approach? The top is bigger and bigger. It just gets bigger. There's no number. It actually approaches infinity. And if that's the case, we say there is no. And I say this in guidance all the time. There's no horizontal. All right, there's no horizontal asymptote in that case. So those are the three cases. Either it simplifies with no x, that's good. There's an infinity in the bottom, so that approaches 0 when the bottom is bigger. Or if there's an infinity at the top, well, then there's no horizontal asymptote. Or you can say there's one at an infinity, but we typically say there's no horizontal asymptote. No, I don't want to do it here. Okay, so let's go over these two functions we have, find the horizontal and vertical asymptotes for them algebraically. And I had a good question. A student had mentioned to me, how do I know which term is bigger on the top or the bottom, if they have the same exponent? Well, it's like when you write any polynomial like a quadratic. We have an x squared plus some sort of x plus some sort of number. All right? Well, yes, there's a 1 there, but technically there are 0 x's here. So this would be bigger than this, and this would be bigger than this one if you were to choose. So there you go. So in our first one, let's take a look at the vertical. Vertical asymptote. So what do I do for vertical asymptote again? Not everybody at once. Thank you. What value of x makes the function undefined? So I've got to figure out, well, what makes this equal to 0? Because I can't have a denominator equal to 0. So I say 3 minus x equals 0. That is a one-step problem to solve. What do I do? Yeah, add x. If I just add x to both sides, that is where I have a horizontal or vertical?
Vertical.
Vertical. It's all right. That's where I have a vertical. It's where the x is undefined. So this is a vertical asymptote right there. Now we need to find the horizontal asymptote. The horizontal asymptote. The horizontal asymptote is what? I take the limit as x approaches positive or negative infinity of the function x plus 2 over 3 minus x. But what do I do? Anybody?
Oh,
Yeah.
sir.
Yes, yes, and yes. All right. I keep the biggest term on the top, which is this, and the biggest term on the bottom. Don't forget the sign. And you get x over negative x in Acacia. What does that simplify to be? Negative 1. So there is no x remaining that we need to put infinity into. So this is where your horizontal asymptote would be. You have two asymptotes, a vertical one at x equals 3 and a horizontal one at y equals negative 1. Not too difficult. Let's take a look at our second function. So, vertically, what values of x make it undefined? Well, the denominator shouldn't equal 0. That's what makes it undefined. So, those of you that started out with x cubed minus 8 equals 0, that's fine. How do I solve that? I need to start by adding 8 to both sides. X cubed equals 8. How do I figure that out? I take the cubed root of 8. You can do that in a calculator in case you don't know. But at this point, yes. At this point, I hope you know, maybe not all of them, but that 8 is a perfect cube, and the cube root of 8 is 2. These will cancel. X equals 2. Is it positive and negative 2 or just 2?
Just 2.
Why is it not negative 2?
Negative times negative times negative.
Yeah, if I cube a negative number, the result will be negative. It'll be negative 8, not positive 8. So make sure you're aware of that. There is my vertical asymptote. Horizontal. Horizontal, we're still finding the limits as x approaches positive or negative infinity of our 4x minus 4 all over x cubed minus 8. What is the biggest term on top? 4x, thank you. What is the biggest term on the bottom? X cubed. So I'm going to take this and I'm going to simplify it. Jared, what's simplify out to be? 4 over x squared, because this cancels with one of these, and that becomes a 2. We have 4 over x squared. Now, we can plug in positive or negative infinity there. Sorry for my small writing. That is 4 over infinity squared. Well, infinity squared is still infinity. So what does that approach? 0. Bam. That is my horizontal asymptote. At y equals 0. Horizontal asymptote.